Righto, so for our second problem, a rectangular paddock is to be fenced with 400 metres of wire. Find the maximum area of the paddock. So, again, I can draw a rectangle of some description. That's really shocking. Please excuse the drawing. Slightly better. Okay, and so in this question, we don't know anything about this other than that we have 400 metres of wire. So what I can do is I can call one of the dimensions x and the other dimension y. Now, knowing that I have 400 metres of wire, that means that I know that the perimeter of this fence can be 400 metres, and I should use all of the wire so that I can actually maximise it. So I'm going to say that the perimeter is equal to, now I need an equation for this, and so I've got x along two sides and I've got y along two sides. So the perimeter is 2x plus 2y. And again, I said I know that the perimeter in this case has to be 400 metres because that's all of the wire. So I can say that 400 equals 2x plus 2y. I can simplify this a little bit. I could divide everything by 2 and so get 200 equals x plus y. That's the first equation which I'm going to create here. The other is that I'm looking to maximize the area of the paddock. So I need an expression for the area, or an equation for the area. And that is that the area is, in this case, we do length times width, which is just x, y. Now the problem here is that we have two variables, and what we want to do is we want to make it so it's just in terms of one variable. So what I'm going to do is I'm going to rearrange the perimeter equation. So rather than 200 equals x plus y, I'm just going to subtract x from both sides, which would cancel these ones out and leave me with y equals 200 minus x. And so because I know that information now, I can substitute that into the area equation. And when I do that, I get area equals x times 200 minus x. So I've now made it so that it's an equation just in terms of one variable, which is much better, and now we can differentiate this and find out where the maximum occurs. First things first, I'm going to expand it out. So the area is equal to 200x minus x squared. And looking at the highest powered term there, the x squared term, okay, I can see that it's negative, and so the shape of this graph is going to look like that. We know it has to have a maximum. I can differentiate this to find where the maximum is. So dA dx is 200 minus 2x. Again, for a maximum, I need to let the derivative equal 0. So let dA dx equal 0. And if I substitute that in, so 0 equals 200 minus 2x. What I can do is add 2x to both sides. So 2x equals 200. And then dividing by 2 leaves us with x equals 100. Now, what we can do next is, if we know that this length x is 100, and that means this length x here is 100, we've used up 200 meters of the wire. And so that means that the other 200 meters must be spread evenly over the y values, which means that they must be 100 each as well. However, we can show this by subbing into one of our equations, and I would suggest using into the perimeter equation, I should say, because we have an answer there. So if I sub that into the perimeter equation, then 200 equals 100 plus y, using this line right here. And so y is also equal to 100. Now that I know that, I can then finally calculate the maximum area. I'll do that back over here. So therefore, the area is equal to xy from this line right here. So that is just 100 times 100, which is equal to 10,000 square meters. So that is the maximum area of a paddock. And you might have noticed that this actually makes it so that it's a square paddock because it's 100 by 100. But it's important to remember that a square is a type of rectangle, but rectangles are not a type of square. So, yeah, that's all there really is in that question there. So we've got the answer over there for the maximum area, and that's all good. I'm going to leave that example there, and we'll pick up with just one more video after this. See you later.